Yes.
Are you okay?
Mm-hmm.
Sorry for being loud to you just now, okay?
No problem.
Accept my sincere apologies, okay? Uh, wait. There's something. I have to undo this. Uh, uh Go on. Today Microsoft is not behaving. It's really disappointing. Hold on. My computer hang a bit. Hold on. It's not you guys. It's me. Okay. Wait. Now I got. Come on, you cheeky sort. Come on. Okay. Home. Undo. Okay. It it does not work. So let me try again. Okay. You cheeky sort. Okay. Not working. It's okay. Okay. So now we want to draw the element. I'm going to draw the element down here. Okay. So it'll be clear to you because there are some important points I want you to see. Right. So now I want to do this. So we're going to draw the element at 30 degrees. Okay, the element at 30 degrees. So I'm going to draw our origin. Okay, so this is our original. Okay, so now we are going to, this is our original axis. So now I'm going to rotate it by 30 degrees. So this is 30 degrees. Okay, now this is 30 degrees. Then we're going to rotate. Okay, so this is our 30 degrees, right? So we did a bit of this last week, but this one there's more points. There's the shear component to add in. And the shear component is the one that usually confuse students. Okay. Right, so that is our element. And then we know that I'm going to draw in a very light line. We know that this is our point Y, right? We know that this is our point X, right? Why that's point? Because on the element, right, this is horizontally is Y, vertically is our X. Okay, that's why I labeled a Y. So if we rotate by 30 degrees clockwise, okay, we should get Y30 on the element. It is 60 degrees. So our normal stress Y30 we calculated to be what? 78.479. Okay, so this is tensile. So this is tensile. 78.479. And then the other side is in compression. The normal stress we have calculated and is rated at what? Minus 47. Is it 47? So 15 minus 63.479. 48.479, not 47. Okay, so this, my apologies. So minus 48.479. Okay, so this is going through compression. 48.479. Okay, now we have a shear component now. Okay, we have a shear component now. Last week example has no shear component. Okay, so let's look at Y30. Okay, so for Y30, right, for Y30, the rotation of the element is what? Anti-clockwise. Okay, so now you look at Y30. So this is our Y30, right? So this is our Y30. Okay, so it states that the element has to go anti-clockwise from Y30. So when that's the case, our shear stress will go up this way. that is our shear stress. Does it make sense? Yes or no? I repeat again. If we look at Y30 now, right, Y30, the rotation of the element has to be what? Anticlockwise. So if the center is our pivot point or our pin, I just hate the word pivot. Just don't catch where. If to rotate anticlockwise, right, the arrow has to go upwards. Okay, so that's our shear. So next, let's look at X30. Okay, X30. So this is our X30. Let me home. So this is our X30 line, right? So now X30 has to rotate in a what? In a clockwise direction. So this is the shear. Okay. So now the shear, we know it is a negative shear configuration. Okay, so you add in these two. So it is sitting at, the shear is sitting at what? It is sitting at 49.953. So 49.953 megapascal. That is our shear. Okay. So what is the difference with this compared to the one last week is the shear component. Okay.
Eugene.
Yes.
Can I just ask a clarifying question here?
Yes, please do.
So the first drawing you did, that was if it was at 0 degrees, and the question was asking what are the forces if it's at 30?
Stresses.
Or stresses, sorry. Okay.
Yep. Yep.
Okay, and that's what that red line is indicating is what if it was 30 degrees?
Yes.
Okay, thank you.
Okay.
And where do you want it to be? You want it to align on the X-plane where you have 0 shear?
How do you mean?
Like, that's where the carbon fiber grain is oriented, but where would you want it to be? Like, you would probably want to rotate it, I think, to the X-axis, right? Like, it's still not in the, like, optimal or ideal orientation.
So the ideal orientation, we calculated. It is, so the ideal orientation, okay, should be theta P, which is equal to 21.8 divided by 2, which is equal to 10.4. Is it 10.4? 10.9 degrees from the clockwise. Okay, that is the optimum. But this question did not ask us to find optimum. If we were to lay it at 30 degrees, what is our carbon fiber orientation? Okay, does that make sense?
And carbon fiber can't withstand shearing. That's why we want the optimum.
Yes.
Okay.
Okay.
Gotcha.
Okay. Okay, Samuel, why X30 be Y30 and Y30 be X30? Samuel, we call it Y30 is because it's from point Y. Does that make sense? Okay. Now it cannot. Hello.
Like, why can't they switch? Like, why?
Okay. I'm coming there now. So it's from X. It cannot be known as X30. Let's say now. Okay, we're going to do from X. Okay. So if we do from X, this will become known as X60. Okay. Now, Samuel is confused now. Okay. And I like that. Right? Samuel is confusing, right? But the answer will be the same, right, Samuel? Hello? Samuel, you there?
Yes.
Right? Respond to me, okay? Because everyone, okay, Samuel, what you're asking is really, really good question, okay? And I hope you respond to me, okay? Why? Because you're helping the whole class, okay? I'm telling you seriously, you're helping the whole class. Why it cannot be? Because these are the questions that everyone have in their mind, but only, pardon my French, only Samuel have the balls to ask, okay, Samuel? Okay, Samuel, okay. So you understand why is it cannot be known as X30 the second time, yes or no, Samuel?
I'm just a bit confused. Like, why can't X30 like be Y30? Like I'm just
No,
trying.
it cannot be. It has to be called X60.
Okay.
Why X60? Because now you're rotating from point where? Point X. Okay. If you're rotating from Y, right, and this angle is 30, you call it Y30. Okay. So, however, if this is X60, right, if this is X60, you will not have Y30. You have to call it X60. Okay. So now let's say we do what Samuel wants us to do by going through X60. Okay. X60 means what? It has to rotate from point X. Okay. So now I come back here. Okay. Now we have to rotate from point X. Right. So point X, okay, to the 60 Y60, because this is 60 degrees now. Yes or no? This is 60 degrees, or this is a messy now. Okay, that's 60 degrees now. Okay, now from X to the carbon fiber rotation is 60 degrees, and now it's going in what direction? It's going into a counterclockwise direction. Yes, right. So from point X to X60, now you rotate here is 120 degrees. And now this point is known as X60, and their directly opposite is known as Y60 now. Okay, your answer will be exactly the same. Okay, so now, right, we come back to this. Now you are calling this X60, and now we are calling this point Y60. Okay, your answer will be exactly the same because we are landed on the same point. Yes or no? We landed on the same point. Samuel, is that are you clear in that, Samuel?
Yes, thank you.
Okay, so that's why you point out something very, very important. Okay, why can't X30 be Y30 and Y30 be X30? Okay, that is a really good point. Okay, so the first point that you see down here, the way of labeling is if you start from point Y and rotate, you call it Y30. Okay, but if you start from point X, you rotate, it's no more 30 degrees. That's where a lot of students, including myself when I was undergrad, I made the same mistake. Are we clear? Okay. Okay. Now we go for another problem. Okay, we go for another problem. And this problem, usually most circle you draw from one element. Okay. So for the next example, we are going to draw most circle from two elements. Okay, and I'll give you a scenario why this happened. Okay, so I'm going to give you another example. Okay, I'm going to give you an example. I'm going to do another example. Okay, example number 2. And please go on to Avenue to Learn. I've uploaded the example question. Okay, if you were to go to Avenue to Learn, you will see another example. Okay, or these figures. Okay, let's go for this example. Okay. So this example in a certain textbook, okay, is the B.N. Johnson textbook. Don't buy the textbook, it's not important, okay. Is if you look at this example, it is at 7.159. What it usually means, the bigger the number, the more difficult the question is, okay. But what I have taught you guys is enough, okay, the knowledge is sufficient to do a complex problem like this, okay, by using Mohs circle. Nothing too complex, okay. So I would like to elaborate on that point, okay. So there's a force P applied in a centric force. Centric means it's applied at the neutral axis, okay, exactly on the axis, as shown, okay. So now, knowing that the stress on the plane AA is minus 15 kS